Once more, welcome to Bawashili Electric. So today, let us try to dive into industrial automation. We are going to look at some simple connection, and that is a motor control circuit called a direct online. We are going to see how to come up with a direct online three-phase motor connection. So I'm using Cade-Simulation software. You can use any software. There are very many. We have ESS, we have Automation Studio, we have SolidWorks. There are very many. Whatever you use, all what we need is the basic on how to come about with the circuit. So we shall see the circuit diagram, as in the line diagram. Then we shall also see how to arrange the real components and do the real wiring and the connection, and you will see how we go around with it. So there we go. Allow me start. So we are going to start right away. I'm going to have a power supply. So here in my software that I'm using, power supply is stipulated here. So I'm going to have this one, which has line 1, line 2, line 3, neutral plus earth. So that is my power supply. So from there, of course, you need to have now the control breaker, and my breakers are around here. I'm going to have a 4-pole breaker. Yeah, there we go. So from the breaker, this one is the power line. The power line from the breaker, we shall have the contactor straight away. And for the contactor, allow me use a 3-pole contactor. Then from the contactor, we can have an overload. Let me try to look for the overload. I'm not certain where it is. Yeah, it is somewhere here. So from the overload, of course, straight away forward, now we shall have our 3-phase motor. So there we go. That is, we have arranged the components. So now let's try to do the wiring. I have here my cabling. Shall get cable roots. Shall connect from the breaker to the contactor, then from the contactor to the overload, then from the overload to the motor. So here in simple terms, we are having line 1, we just connect through all the components up to the motor, and line 2 and line 3. So for the neutral, we shall, no, I'm still on a 3-line connection. Let me choose single line. This is the neutral wire. So for the neutral, it will have to stop only in the breaker for the power line, because we are not going to use it in the power, as our motor has only earth, line 1, line 2, and line 3. So for the earth wire, which is this one, protection wire, we shall draw it directly to the motor. Like that. So that is our power line. So when we try to run this one, actually it can't run, because when I do here simulation, we shall be able only to power the breaker. But now remember, this one is a contactor. How do we power on a contactor? We need some control circuit. It is not mechanically operated, it is electronically operated. There we go. So you can have our control circuit. We are going to use the very power from the power line, from the power circuit. So we are just first going to have our control breaker here, our 2-pole control breaker. Then from there, oh sorry, this is a contactor, so delete, 2-pole circuit breaker. Then from there, we are going to have since we have an overload, we shall allow it operate. We are going to have an overload contact, so we shall have here under contact shall get a normally closed. Then we shall have something to act as an emergency switch. Under switches we need a toggle switch. That's the limit switch, push button, okay. If it gets lost, we can use just normally closed emergency. Then we shall have a stop. Then we shall have a start. We'll use a normally open. Then from there we shall have a coil. A coil on operation coil, like there. So we shall also have, we need a latching contact. We shall have a latching or a holding contact. So before we do the routing of the cables, we need to do what we call addressing. As you see, this one is S and this one is S. They should not be of the same address, because when they are of the same address, let me show you here. When I complete this one, it means all of these ones which are of S, they are going to be affected. So how do we do away with that one? It means you have to give them different addressing. So this one, maybe we can call it S2, or this one we can say it is MCB. Then this one is MCCB. Yeah, then this one, it is for overload, TH, thermal relay, of which we shall also name it here thermal relay. Then here we shall have our emergency, and say emergency. Then we shall have stop. Then we shall have start. Then this one is for this contactor here, because it is the one you need to select hold. So we shall give it the same address, KM. As well as this coil is also for this contactor, the A1 and the A2. We shall give it KM. There we go. So I think we can start the cabling. So here I'm going to give this one, we are going to use live wire. We're going to connect the phase through the overload, normally closed of the overload. From the overload, you are going to go to the emergence. From emergence, we have the stop. From stop to the start, it is in parallel with the normally open of the contactor, 13, 14. From there, again, we go back now to A1. That is phasing is done. So now we shall have the neutral, which we shall take somewhere like this. Then I bring it down. Then I finish up to A2. So now we need to give it the breaker power. Control Z. So on the phases, we can choose any live phase to act as the live, or allow me use phase wire. down the breaker. That means that this main MCCB, when it is off, it has to power off everything, even the control circuit. So there we go. I think the circuit diagram is done. So what is remaining is only to do the simulation of our work, and we see the outcome results. So now we do simulation of our circuit and we see what happens. So I'm going to click here, simulation, play. Then of course now we first have to close the main MCCB. As you see, power can reach the contactor. So now we also close the control breaker, that is the MCB. So now we can click on start. You see, once we click start, our motor starts running clockwise. As you see, it is coil is energized. The launching contact is still holding the power line to the A1 terminal. When we say stop, it goes off. When we say start, so that is briefly how we go about with direct online unidirection. That means a singular direction. So let's continue and see how we can do the real wiring of the real components, and we see how neat it can be. So we are going to stop simulation. Then on my software, I don't need to create a new document, but there are some simulation softwares where you have to differentiate between the circuit diagram and the real diagram. So but mine, you just use the same type of document to give the diagram we want to use. Only it is the power that's going to remain almost the same. So I'm going to have still my power. What I've started with is still the power line. This one is a circuit diagram. Here I now want to do the real wiring, in case you come to the panel or you're given the motor and you're given the real components. How do you go about with the wiring? So when I come here to 2D, after the power, I will need a 4-pole breaker, of which I have one here. That is my breaker. Then from there we have the contactor. Which is there. Then after the contactor we shall have the thermal overload. Allow me pull it down a bit. Shall have the thermal overload. Then after the overload we shall have, of course, now the real motor. This is how these components look in real life, though they differ according to standards and manufacturers. So allow me give the same address. Power supply shall remain X because it is the same we are using, but this one shall call it MCCB. Then we shall have this one KM, of course. Then thermal overload, we shall call it TH, thermal overload relay. Then of course motor shall remain M. So what next is the routing of the cables for the power line. I have power to breaker. I have from breaker to contactor. Then from contactor to overload. Then from overload I have to take it to the motor. So that is how it is. With the neutral, actually let me connect earthing. I shall take it direct. then neutral shall only stop in the breaker. We shall need it when we want to wire the control circuit. So that is it. I think we are now done with the power line. We can go to control. That is how we arrange our devices in case we are given these devices and we want to do the wiring. These distances today doesn't matter. Some overloads, as we know, they are stuck direct into the contactor. Okay, now we go to the control. Now, to make matters worse, my software doesn't have a breaker which is not a 3-pole breaker. So I'm going to have an emergency switch. But before the emergency, I have to go through the thermal overload. Okay, we shall see when we are coming to wiring. So this one, I'm going to change its mode. Yeah, that's emergency. Then I'm going to have the stop button. It is that one. Then shall have a start. So now the other thing also, when we are doing the rewiring, what we didn't consider in the circuit diagram here, it is what we call the terminals of DC devices. Remember, thermal overload here, it is always, what about remind me, 96, 97 or 97, 98.
For normally closed.
Normally closed.
97, 98.
97, 98. If I'm mistaken, please you can cross check on the real materials and see. Then the emergency is always 1 and 2. Are you sure? Then the stop is always also 1 and 2. Then the start is always 3 and 4. Then this is 13, 14, this is A1, A2. Yeah, that is how it is always. So that is what we are going to consider here in the real wiring. Emergency should use 1, 2, like that as we move on. So we are going to get our power line. Allow me use this one, phase. We are going to go to cable routing, get phase. Then we shall have, yeah, from phase to emergency. Now there are some engineers, it doesn't matter what you consider first. Some from power they first take through the overload, others first through the emergency, the one I'm doing, then the stop, then it is the neutral that they pass through the overload, provided the circuit can be broken when there is an error with the overload. We shall see during simulation. So from here, allow me align my components. So back to cabling, from 2 to 1, we are trying to follow what we did here. Then from 2 we are going to 3, as it is here, from 2 to 3. Should you go back to 1 and 2, you shall have used a wrong route. Then from there we went to the coil. Yeah, to A1. I'm going to use A1 as my positive coil, then A2 shall be the neutral. So that one is the positive line. Done. So when we come to 13 and 14, we shall get from around here. As we see, it is getting from either pin 2 or pin 3. So I'm getting from pin 2 and take it to 13. Now allow me do it the vice versa. It is all the same. I'm going to take it to 14 because it is the one nearer. Yeah, I can zoom this and you see it very well. It has entered pin 14, is around here. So now since it has entered from 14, it will come out from 13. I've just done the vice versa. So from 13 here, it's going to come back to the coil. That is how we are going to do the retaining. Allow me zoom back. So we have already finished the 13 and 14. So what are we remaining with? We are remaining with A2, which is here. We have not yet connected. So here the overload we are going to use, it is always, let me zoom, we see it very well. Normally closed is always 95, 96. Yeah, this one deceived me. So we are going to use 95 here by 96.
95, 96.
95 and 96. So allow me zoom back. I get space for wiring. So we are going to have our neutral. Allow me get here the neutral wire. Through 95 then as it enters 95, it comes out from 96. Then it visits my A2. So only the difference that I've made from the circuit, it is here in the circuit, it is the live that we passed through the thermal overload, but now in the real wiring, just because of space, I've passed it through the neutral. Like if I complete it, if I demonstrate what I've done here, this one I've just made a complete like that. Then I got the thermal overload and I placed it around here. So when I do the routing here, yeah, that's what I've done. It remains the same functionality, because also here it's going to do what? It's going to break. Only here that the addressing, I do the real addressing, some overload. So we are going to give our real wirings the very addressings of the circuit wiring. This one is TH. So here we shall have emergency, it was EM. Then we shall have stop. Then we shall have start. Anything else remaining? I don't think. So after that, what is only remaining is to do our simulation, and we see whether we are right or wrong. Yeah, so now we were trying to do the simulation. Let's simulate and see. So as these circuits are now connected together just because of the same address, and you can see when I power on here, let me say simulation here, when I power on here, the same this way also it powers on. Doesn't mean that when you're doing this wiring, maybe in the panel that's what happens, that maybe you'll have two different circuits, each being controlled all together. No, just this one is the inner view or the circuit view, but this is the real components. So when you turn on the control power, so when you press here start, you can see this way it is already what running. When you press stop, it goes off. But unfortunately here, when I say start, this way it runs, but this way the overload, I think it is faulted. This line is not completing. Let's try to omit the overload and we see. So I'm going to delete this one. I'm going just to connect straight. So let's try to simulate this one and see. So when I press here start, simulation first, play. Then when I complete this breaker, even this one, so start, you see the motor is running clockwise the same as this one. The breaker, the contactor has already latched. Are you seeing? When you press emergency, it goes off. So that means we had used a faulty overload. So engineers, please, you have to put that into consideration, testing of the equipment that you're using. But since this is software, they have bugs and errors and whatsoever, but the basic component, the basic concept, it would be first passing through the 95 and the 96 of the overload, whether through the neutral or through the live, it will break the circuit. It does not matter. So start, our motor runs as you see. Thanks for watching. I shall not go into much details more than that. A word to a wise is enough. So a simple explanation to an engineer is enough. See you when you see me.